Hello Algebras, welcome to part 2 of a long day of lessons. Now, we are picking up right where that last video left off, so we are on page M325. And the question is, how can we restrict the domain of g of x so that its inverse is also a function? Well, if it's not a function because it doesn't pass the vertical line test, if we eliminate this bottom part, then it would be a function. So we can restrict the domain to have only the positive x values. So x values that are larger than, equal to or larger than 0. So once that we can restrict it to that, then it will be a function. So when we restrict it to that, notice our notation changed from y equals to g of x, and then that little -1 power, that is the symbol for inverse. Alright, so now we no longer have that plus minus, it's just positive. So our domain restrictions, x has to be greater than or equal to 0. So our domain, remember domain is where it exists left and right, the x values. So for our parent function, domain and range are still going to be the same. Oh, wait, sorry. The domain is all real numbers. I lost my train of thought, sorry. My bad. So the domain would be all real numbers. The range is still y is greater than or equal to -4. In interval notation, it would be -4 to positive infinity. So with the domain restriction, our inverse function will no longer have this bottom part. So it'll just be there. So our domain still is going to exist from -4 on. Or in interval notation, like that. But our range now is not going to be all real numbers because it doesn't exist up and down everywhere anymore. It only exists above a y value of 0. Or in interval notation, 0 to positive infinity. All right, so again, what conclusions can you make about our domain and range with the domain restrictions? Is there anything you can conclude? What's different? What's the same? So on and so forth. So answer that on your own. All right, our next example, slightly different, almost the same, but our equation is written differently. So again, it's asking how would it be transformed from our parent function. So our parent function, you know, is here, and it would be transformed 4 units to the right. Again, I'm not gonna get hung up on the transformation side of things. So let's go to our writing the equation of the inverse. So remember that function notation is just y, so it would really be y equals x minus 4 squared. So if I swap places, now I have x equals y minus 4 squared. So those parentheses are really a big deal. Like, depending on where the parentheses are, depending on where your exponent is, you're gonna take different steps to solve. And as I said in my previous video, whenever we're dealing with graphing, solving, functions, anything, if you have an equation that is not solved for y, you are not finished and you will not be able to answer the questions you need. So right now we are not solved for y, we need to solve for y. I can't add or subtract anything first because this is all grouped together under that squared. So I need to square root both sides. So I have plus minus x equals y minus 4. Now I can add the 4 over. And so I have plus minus the square root of x plus 4. And make sure that that plus 4 is noticeably outside of the radical. It is not underneath that radical. Again, if you don't like your y on the right hand side, which I don't, I'm going to rewrite it. So this is the inverse of that. So notice that the inverses of the functions have essentially the opposite of whatever's going on. Notice we have a minus 4, we have a plus 4 in the inverse. Notice we have a squared, notice we have a square root in the inverse. So it's inverse really just means the opposite. So let's go ahead and graph this. So again, I'm going to select x values that make my life easier. And the x values that are going to make my life easier are perfect squares because our x is under square root. So 0 is perfect square, well, kind of. 1 is perfect square. 4 is a perfect square. 9 is perfect square. 16, so on and so forth. Okay. All right, so when I substitute 0 in, the square root of 0 is 0, plus 4 would be 4. When I substitute 1 in, the square root of 1 is 1, plus 4 would be 5. The square root of 4 is 2, plus 4 is 6. And again, I'm substituting into the inverse function. The square root of 9 is 3, plus 4 is 7, and the square root of 16 is 4, plus 4 would be 8. All right, so let's go graph these. So we have 0, 4, 1, 5, 4, 6, 9, 7. All right, and 16, 8 would be off. Now, let's look at our equation. We have the plus minus in front of the square root, so we have to take into account the negative values as well. So just like our last one, it's going to mirror them. Oh, the reason it's mirroring them, so if we have so we have -1 plus 4, which would be 3, so it's 3. Here the square root of 4 is 2, so you'd have -2 plus 4, which would be 2. All right. All right, so there we have it. Is the inverse a function? Well, let's get out the handy dandy vertical line test. No, it is not. Failed. All right. Transformation from a basic square root inverse function. It's just up 4 units. All right, next, let's list the domain and the range. So our inverse is plus minus the square root of x plus 4. The domain of our parent function, if you will, would be all real numbers, because this is going to continue to go on forever and ever. And it's going to hit every x value along the way. So all real numbers, or in interval notation, negative infinity to infinity. Our range, remember, range is up and down. It exists everywhere above a y value of 0. So when y is greater than or equal to 0, or in interval notation 0 to infinity. And if you're doing interval notation, bracket means it's included. That means not included. So essentially that would be if it has equal to, and this is if it's not equal to. Okay. The reason you have the curved edge for infinity is because infinity never stops, so therefore you can't cap it off anywhere. So it just keeps going. All right, let's look at the inverse domain. So our inverse domain, remember inverse is x, so it's going to hit every x value along the way out here, but it's not going to hit any x value that is less than 0. Okay. It starts on an x value of 0. So our domain exists when x is greater than or equal to 0. In interval notation, it would be 0 to infinity. And our range, so these are going to continue to get wider and wider and wider and hit every y value along the way. So our range is going to be all real numbers, or in interval notation, negative infinity to infinity. Right, what conclusions can we make about the relationship between the domain and range of the quadratic function and its inverse when it is not restricted? So kind of internalize that, think about it, see if there's any similarities, any differences. And then we're going to talk about when we restrict it in the next video. Right? Happy mathing.